Hello and welcome. In this video we are going to look at an example of conducting a goodness of fit test for a non-uniform distribution. So this example says you are conducting a multinomial hypothesis test for the claim that the four categories occur with the following frequencies. And they give us that the first category, A, has a frequency of 0.3, the second category, B, has a frequency of 0.2, third category, C, has a frequency of 0.3, and the fourth one is 0.2. Complete the table. Well, we have the observed frequencies here. Since we have the observed frequencies here, we know that there is a total in the sample of 40 plus 22 plus 26 plus 20. So 40 plus 22 plus 26 plus 20 is 108 in this sample. The expected frequencies we will find by doing n times p for each cell or each entry. So for the first one, we'll have 108 times 0.3 times 0.3 would be 32.4. I'll zoom in a little bit so I can, too much. There we go. For the second one, we will have, again, I'm going to get rid of this so I can write a little bit further to the left. 0.2, so 108. Nope, I missed the 0. Whoops, I missed the 8 times 0.2 is 21.6. Third one is 108 times 0.3, which we already did, is 32.4. And then lastly, I forgot to write that, give me a second. 108 times 0.2 again, which we've already done. It's the same probability or the same outcome as B. So we'll have 21.6. So to find the squared residual, we will just do the observed minus the expected squared. But I'm realizing that I should probably do this off to the side because I don't think I have enough room. Let me just grab all of this. Sorry. Divided by the expected. So I'm going to do these off to the side so I have more room. So for A, we're going to do 40 minus 32.4 squared over 32.4. For B, we're going to do 22 minus 21.6 squared over 21.6. For C, we're going to do 26 minus 32.4 squared over 32.4. And then for D, we're going to do 20 observed minus the expected over 21.6. So we're going to do 40, I should probably use parentheses, 40 minus 32.4, close parentheses, squared, divided by 32.4, enter. We'll get 1.783. For the next one, we will do parentheses 22 minus 21.6, close parentheses, squared, divided by 21.6, we'll get, did I do that right? 22 minus 20. Oh, yes, because they're very, very, very close. There's only a difference of 0.4. So this would be a very small value. Also, it says to round to 3 decimal places, which is why I'm doing that. The next one is 26 minus 32.4. I forgot the parentheses. We'll go back in here and insert the parentheses. Second insert, parentheses. We'll go way back over. Squared divided by 32.4. We'll get 1.264. And then lastly, we will do 20 minus 21.6 squared divided by 21.6. We'll get 0.119. Sorry about that. I was also getting ready with the next step in the calculator. So to find the chi-squared test statistic for this, we're just going to add up all of these values. So we'll do 1.783 plus 0.007 plus 1.264 plus 0.119. Press enter and we'll get 3.713. I'm sorry, 173. But I also wanted to show that we could do the hypothesis test using the chi-squared test in the calculator. So first thing we would do to run a hypothesis test with this would be to press stat and then press enter and then enter all of our data values into L1 and L2. So observed goes into L1, expected goes into L2. Then we'll press stat, go to the right twice to tests. It's easier to go up. We're going to choose the chi-squared goodness of fit test. And then press enter. Our observed is L1, our expected is L2. The degrees of freedom is the number of categories minus 1, so 4 minus 1 is 3. And then press calculate. It will give us our chi-squared value of 3.1728 or 3.173 and our p-value of 0.3657. So this one would be a fail to reject test.